Okay, let me welcome you on this session on sharing of data, and then especially session C1 on the global initiatives there are in order to, let's say, make bridges between the regions. When we were asked to set up this series of sessions about how the research infrastructures can share their data globally, we suggested to the organizers that we would look not so much at the research infrastructures and what data do they produce, but rather look at the infrastructures that are in place or coming in place in the near future, hopefully, that can help the researchers from the research infrastructures to share their data globally. And therefore, we decided to make this into 3 sessions, 3 levels. The first session which you're in and which is starting now. Then the second one, sorry, let me first say this session is about how these regional initiatives, like in places in Europe or the United States or other regions of the world, talk to each other, what the interaction is in order to think in terms of a global impact of data sharing or a global approach to data sharing. The second session after the lunch, C2, will be devoted to some of the regions. For example, the region I work in myself in Europe, the European Open Science Cloud will give a presentation there, and a few other presentations will represent other regions. The third session at the end of the day, the end of the afternoon, will be examples from countries involved in these regional initiatives. There's, for example, a talk from Germany, but there's several other countries, as you can see in the program. So we have tried to structure the whole thing in, let's say, what is done in order to talk globally to each other. Secondly, what is done in the different regions of the world in order to bring things together, and what is done in the several countries that are parts of those regions. We have in this session 5 speakers, and we just decided in your program it says that Michael ARENTOFT is going to be the first speaker. I'm not going to introduce him because he's going to be the last speaker. We just agreed, overviewing the presentations that have been given. That means that our first speaker will be Simon HODSON. Simon is the Executive Director of CODATA, and he has been sharing the expert group of the European Commission on fair data that wrote the report Turning Fair into Reality, a report which is used very often by a lot of organizations and people. Simon is online if everything is okay, and I would like to give Simon the floor.
Thank you very much, Karel. I trust everyone can see me.
Can we have Simon on the screen here? Yep, there you are, Simon. Okay. Go ahead.
Hi, everyone. Good morning. Thank you very much for the invitation. So as Karel has kindly said, I'm Simon HODSON, Executive Director of CODATA. CODATA is, as you can see on that title slide, the Committee on Data of the International Science Council. Very quickly, the International Science Council is a global representative body of academies, other science institutions and funders, and the international scientific unions. It can genuinely claim to be the global voice of science because it's a representative body of scientists, and although it's got very close relationships to the UN system, it works in parallel and with UNESCO as the UN entity for science. And that's important because the member states of UNESCO obviously are important decision makers in global science, but it's essential that we also have the voice of science from those scientific institutions and from those representative bodies like the international scientific unions. That's the International Science Council. CODATA is the Committee on Data of the International Science Council. We're not just a committee. We're an organization with our own legal identity and our own finances, but we exist to serve the mission of the International Science Council, to advance science as a global public good, and CODATA specifically by addressing issues of fair data and open science. And so, yes, as Karel kindly said, I chaired the European Commission's expert group that produced the Turning Fair into Reality report. And I was also the vice chair of the expert advisory group for the UNESCO recommendation on open science. So that gives an idea of the sort of things that CODATA does. We also have an international data policy committee, task groups on data science issues, and a set of projects and programs. And I'll introduce or talk about one of those activities now. So the theme of this presentation, as I mentioned, is to introduce the GOSC initiative, which is Cooperation, Alignment and Interoperability for Open Science. GOSC stands for the Global Open Science Cloud. Now, to be absolutely clear, we do not propose to create a global open science cloud, but we do propose to encourage and support and facilitate that mantra: cooperation, alignment, and interoperability among the various open science infrastructures, initiatives around the world, whether they call themselves clouds or platforms or commons, whether they call themselves open science or open research. We chose this title, Global Open Science, because it reflects the language used in the UNESCO recommendation. And we see as our driving mission in this initiative and in CODATA activities more generally, as responding to the UNESCO recommendation and also the strategy and action plan of our parent body, the International Science Council. So on this slide, there are two quotations from the UNESCO recommendation and then from the International Science Council action plan. In the call to action of the UNESCO recommendation, calls for the development of many things, of human capacity, the development of open science policies and awareness raising, but also for the development of open science infrastructures to support those emerging practices for the science of the future. And so it calls on member states to promote open science platforms and infrastructures, and crucially, to ensure that there is collaboration among those infrastructures. In typical UNESCO language, it talks about north-south, north-south-south, and south-south collaborations. But the point here is twofold. One, we need to ensure that those infrastructures do not create new silos. And we need to ensure that the new type of science, the science of the 21st century, open science, is something that's shared throughout the world, and that in the UNESCO mantra, no one is left behind. The International Science Council has a very similar take on open science platforms, essential for open science practices, but also we need to ensure that the Global South is part of the dialogue and is an actor in the dialogue. So those are two important drivers, and they have led to some work that CODATA and the International Science Council has been doing for a number of years. So we have engaged with the pilot project that led now to the African Open Science Platform and the vision and strategy document, which we contributed linked from that slide. And we've also been engaging with the initiative in Malaysia for the Malaysian open science platforms. And of course, in other work, engaging with the European Open Science Cloud, with initiatives elsewhere in the world, with ARDC in Australia, with activities in Latin America, and with the CST Cloud in China. So I've mentioned some of these initiatives which are emerging around the world. We see a pattern emerging of investment, sometimes in particular nations, Australia, Germany, Canada, Malaysia, sometimes in regions or continents, the European Open Science Cloud, the African Open Science Platform, activities in Latin America as well. There is a shared mission of these various activities: to advance and support open science and fair, of course, to facilitate the science of the future, to achieve economies of scale and greater impact and return on investment, of course. And I think there's also of interest for ICRI as a conference, representing those research infrastructures. I think there's there's two additional drivers which are worth mentioning. One is vertical alignment or vertical proximity. And by that, I mean bringing those e-infrastructures closer to the researchers and their needs. I think we would all admit that there remains a shortfall in genuinely providing services that serve the needs of particular research communities and getting them to use the research infrastructures that are available to them, really tailoring those services to their needs. There are a lot of good examples of very good work, but I think there is still policymakers and infrastructure specialists and researchers themselves will still say there is a shortfall. We need to bring those infrastructures closer to those research groups. Secondly, and this is to repeat a theme, is this horizontal interoperability. We have created, on the one hand, research infrastructures for the needs of particular domains, but we're increasingly finding that the research of the 21st century is cross-domain and needs to address global challenges, which in their very nature are interdisciplinary. Think about climate change and climate change adaptation. Think about the growth of cities. Think about the biodiversity challenges. All of these areas that respond to the UN SDGs or to disaster risk reduction, etc., require data that was originally in what we consider the natural sciences, biodiversity data, earth science data, etc., oceanography. And for that to be combined with, to be modeled with data from the human sciences, data about the built environment, data about attitudes and behaviors, data from our societies. The science of the 21st century that addresses global challenges and that relates to the Sustainable Development Goals is fundamentally cross-domain interdisciplinary. And so therefore we need to break down the barriers between those research infrastructures in particular domains and of course ensure that we can address those global challenges, that global research which is needed, by ensuring that we're not building silos in Europe, in Australia, in China, in Africa, and elsewhere. So we need that cooperation among those clouds. So, how do we hope to contribute, among other activities, which you'll hear about in this session, to that mission of breaking down those barriers and encouraging alignment, of cooperation, alignment, and interoperability? So the Global Open Science Cloud Initiative is convened by CODATA. It sees itself very much as a bottom-up activity. And I'll mention a top-down activity which we're involved with as well on the last slide. The methodology is to have, on the one hand, a set of working groups that address key topics of shared concern. All those infrastructures I mentioned, those open science platforms and clouds, need to think about their strategy, governance, and sustainability. They need to address legal and policy interoperability, the rules that are laid down about the sharing and access to data. They need to have technical interoperability and alignment of their infrastructure so that data can be accessed under controlled conditions, protected where needed, and accessed where possible and appropriate. And we need data interoperability so we can combine those data across those different research areas. So those thematic working groups are doing the work on those issues of shared concern. But at the same time, and I think this is a crucial part of the methodology, we have a set of case studies. There are 5 listed there. We have a further one which will be added, which has just been proposed. They look at concrete examples of data sharing across particular research infrastructures to understand and, in a sense, to keep us honest so that we make sure that the work of the working groups relates directly to concrete use cases. And those are listed there, and some of those are, so the incoherent scatter data diffusion is a collaboration between ICRI, which is the European infrastructure, and CISA, which is the Chinese infrastructure. The raw diffraction data is looking at the publication of raw crystallography data by the Japanese infrastructure, and that's coordinated by the International Union of Crystallography. The biodiversity case study is led by GBIF, which is the global infrastructure for biodiversity data sharing, etc., etc. We had a recent meeting. We called it an all-hands meeting, our regular 6-monthly progress meeting, and those case studies in particular have made some excellent progress. So I was very reassuring. This is my last slide, and I hope I haven't spoken for too long, and I hope that's given an idea of the motivation and the activities within the Global Open Science Cloud initiative. It's a partnership to bring genuinely global collaboration for open science infrastructure. CODATA is providing collaboration and support for coordination of the working groups and the case studies. We hope to organize an international symposium sometime perhaps in Q2 of next year. Our colleagues at CNIC, which is the Center for Network Information of the Chinese Academy of Sciences, they have set up an IPO, an International Program Office, which will help and which is helping CODATA in the coordination of some of those working groups and case studies. And what I want to mention also is OSCAR. Now, Jean-Claude Becherman will speak about this later, but we see this as a relating activity. And I want to mention it because while we see GOSC, the Global Open Science Cloud, as being a bottom-up activity, OSCAR is a bottom-down activity. CODATA is providing secretariat support for this, and it's a periodic meetings of the leadership of these various initiatives. There'll be an important mission-setting meeting next week in Leiden, and as GOSC is coordinated by CODATA, but with, as I said, with the mandate of the International Science Council. So the International Science Council is very supportive of and wants to see OSCAR go forward successfully. And following discussions yesterday with the ISC, I will propose next week that a future meeting be hosted, of OSCAR be hosted by the International Science Council. And the International Science Council is lending its support, an endorsement and mandate to both of these activities, the Global Open Science Cloud and the Open Science Cloud Executives Roundtable. And I think that reflects the mission and the desire of the International Science Council to support and encourage this cooperation, alignment, and ultimately interoperability of the various infrastructures around the world. Karen Payne, who's coordinating the RDA's initiative on the Global Open Research Commons, will speak later in this panel. And of course, we're very keen to cooperate and collaborate with that initiative as well. And we think they're appropriately complementary in terms of their foci. So thank you, Karel. Hopefully that was clear. Thank you very much. I'll be happy to participate in the discussion and answer any questions that we come on to it.
Thank you, Simon. Before we continue with the next speaker, are there any questions for Simon at this stage? We also will have a panel at the end where we will address all speakers and all presentations. If not, and I don't see any questions online, which I can see on this iPad. So I suggest we move on to the next speaker, just introduced by Simon as Karen Payne. Karen is the first director of the World Data System, and she will explain herself what the position of that exactly is within the system and what you are doing. Karen, the floor is yours.
Thank you. Good morning. It's a pleasure to be here today. I assume everyone can hear me. It's a pleasure to be speaking to you on behalf of myself, my colleagues, CJ Woodford, the co-chairs and members of the Research Data Alliance, Global Open Research Commons, International Model Working Group. And so I'm going to talk to you a bit about what that working group is, what we're doing, and where we're going in the future. And just for the record, I am the director of the International Technology Office, which is a new office in the World Data System. There's also a director that's been around for in the old office, the International Program Office, for quite a while. So the first thing you need to know about the GORC Working Group is that we work under the umbrella of the Global Open Research Commons Interest Group at RDA. And the reason why that's important is because the, whoops, did I do that right? The interest group has provided two really important guide rails to the work of the working group that's really helpful. The first thing that they did was to define a commons as a trusted ecosystem of research services. And we recognize that commons are being built, as Simon mentioned, all around the world in different sorts of contexts. And we all adhere to this sort of ambitious vision of a global open research commons, where a researcher can get access to any resource, any data, compute, software resource that they need at any time, no matter where they are, particularly in pursuit of global grand challenges. So the working group then, in pursuit of this ambitious vision, was set up to identify features, attributes of commons that are being developed around the world. We're not interested in judging or certifying or anything along those lines. We just want to see if we can identify features that users and developers would expect to be there. So for example, well-defined decision-making processes, authentication and authorization infrastructure, methods to manage persistent identifiers for different types of content. All of these are expected features or attributes of a commons. The idea is that we want to identify these to help create areas of common interest and identify areas for future projects down the road. So the second thing that the interest group did, which was really helpful, was to create a topology of a commons, or what they refer to as essential elements or contents of a commons. So in the light blue, underpinning a commons are the digital sort of underpinnings of a commons. The white elements are the more human-centered elements of a commons, and at its core is the interoperability and standards at the core of the commons. And that interoperability is both technical interoperability and organizational interoperability as well. So the working group is using this and testing this topology. And the way that we're doing that is that we have really been fortunate to engage a number of commons around the world in the working group. So we have domain commons represented by the International Virtual Observatory Alliance, the Arctic Data Interoperability. We have pan-national commons represented by EOSC, the Nordic Infrastructure, and the African Open Science Platform. And then we have a suite of national commons in Canada, Brazil, I can't read my own writing, Korea, China, Japan, Malaysia, and Australia. And so we are very, very fortunate to have these representatives from these organizations work with us in our working group. And in particular, the work of the working group to date has focused on a speaker series. And the speaker series has provided a lot of content to the working group. So we have the presentation by the aforementioned groups. We have also got a questionnaire, which we've submitted and had the representatives fill out. As part of that questionnaire, we've asked them to identify services that they are either providing or planning to provide in their commons. Our checklist was based on the e-infra standard, which many of you are probably familiar with. It's the schema that's used to identify research services in EOSC. EGI uses it, OpenAir uses it. So it's a well-established, particularly in the European context, standard. And so we've asked them to self-identify their services according to this standard. And I'll explain why. It's a tiered system. There are super categories with constituent categories and further refined into subcategories. And I'll tell you in a minute why I'm pointing that out. So in addition to the speaker series, we have input from, we have looked diligently at all the commons information that we could find publicly, whether that's the services and platforms themselves, anything from their parent organization or their funders. We've done our review on the commons. We also have what are referred to as the foundational documents of the working group. The working group case statement went through, I think, 4 iterations with public comment and has a lot of good information in it. The GORC typology, which I just showed you, has an associated definitions document, which is also very interesting. We have also thoroughly gone through all existing Research Data Alliance working group and interest group outputs to date for any relevant information. What's not reflected in this slide is that we've also gone through a number of foundational documents that are outside of the RDA, things like the EOSC interoperability framework, the UN big data maturity model, things like that. So then taking this all together, we are looking at ways in which we can analyze and bring together this information and make things useful. So the first thing that I'm going to show you today is that, and the first time we've showed it publicly, is what we refer to as the e-infra matrix. So remember, we asked representatives of the commons to identify their services. So we've created a little tool. I can't do a live demo, but I've got some still shots here that'll give a flavor of it, but you can go to that URL. This is an interactive graphic that sort of portrays where we currently are. This is ongoing. The speaker series is ongoing, so this will change, but this is our preliminary result. At the center of this graphic are the e-infra super categories. If you click on any super category, it will take you to its constituent categories. So clicking on processing and analysis, you see 3 different e-infra categories. Clicking on any e-infra category, like data analysis then, would take you to the outer 2 rings. The next ring is the % of commons in our speaker series who are providing services in that category. So either none of them are, some of them are up to 50%, most of them are between 50 and 100%, or all of them are providing services in that category. The outer ring is if most or all of the commons in our speaker series are providing services in that category, then we name those subcategories. So it was intended to show areas of agreement or overlap or mutual interest or energy or investment, right? So unsurprisingly, all of the commons that we've reviewed so far are providing access, publishing, and discovery of data services. And that's obviously a core interest in any commons around the world. That's certainly one of the reasons why the World Data System is so invested in this work. We represent a consortium of data managers and data repositories with a huge amount of resources and expertise that are vital to the success of this global vision of the GORC, and one of the reasons why we're so heavily invested in this. Excuse me. So it was designed to show areas of interest, but it can also be used to show potential areas of growth. In particular, our preliminary analysis shows that there's very little training and support services that are being provided by the GORCs, and this is a potential growth area. It's also interesting that this is something that has been touched on in a number of the sessions I've spent in. So I do think there's going to be more of this going forward. So the e-infra matrix is great. The e-infra standard is really, really well done, but it was never designed to capture all of the elements of a commons, particularly those elements that are associated with governance, sustainability, user engagement, that type of thing. And so what we have is a running list of all potential attributes of a commons that we've found from our input sources. It certainly includes all of the e-infra services, but also a whole lot more. When we identify those attributes as being something that is part of our commons that we're reviewing, if we see it in the wild, then we identify that in a matrix. And in practice, this is what it looks like. This is the tab for the governance essential element in the topology. We have a list of potential attributes. We have a source for that attribute. This is actually the first source. If we see that attribute anywhere else, we have another document that lists all times that attribute has been repeated in different contexts. If we see that attribute in the wild, we have a source. The series across the top is our speaker series, IVOA, Japan, Europeans, ARDC. To date, we have about 350 attributes and growing. And the task of the working group now is to revisit these potential attributes, look at the language, determine what the appropriate level of granularity is, determine if the topology works, if we need to address anything in the topology. But that's the core task facing the working group right now. In addition to the attributes, when possible, we're collecting a running list of key performance indicators that are used by commons around the world. This can be how a commons would measure their success or development, or how they measure user engagement. All of this will be turned into some sort of final output. The form of the final output is an active area discussion. There will be some sort of attribute model. possible set of KPIs, a couple documents. But really what we're most focused on is making sure that we provide high quality input to a roadmap for commons integration that's going to be developed by the interest group, our parent interest group. I will also note that we're also playing around a bit with some classifications of the commons based on different attributes, but that's a story for another day. That's not ready to be revealed yet. So we have about a year left in a working group. As I said, we're refining the attributes now and testing the essential elements. We have an upcoming workshop, hopefully, as part of the P20 meetings in March in Gothenburg. And then, as I said, we will be working on our contributions for the roadmap for commons integration. I will note that in my office, we recognize that that roadmap will be dependent on existing infrastructures. And so we have created 3 very large reviews of data flows in virtual research environments in the health and genomics sector, in the biodiversity domain, and in the Earth observation domain. And so my task this winter is to get those published. So I think that's all I have to say. It's not too late to join us. You can join us online. You can send me an email if you've got any questions about that. But I do want to thank very much the Digital Research Alliance of Canada and Ocean Networks Canada for their support of this work. Thank you.
Thank you, Karen, and it fits perfectly with the presentation of Simon before. And the third one we will hear is about OSCAR. Simon called it the Open Science Cloud Executive Roundtable. It should be the Open Science Commons Executive Roundtable, but that's okay, that's a detail. These words are used interminglingly. And after the presentation of Jean-Claude Bulgerman on OSCAR, we will have a presentation on a specific element on the PIDs. So in this way, we have structured the model, and then Michael will give sort of an overview from his perspective. Next speaker is thus, sorry, I forgot, if there are questions for Karen. Sorry, Karen. I didn't see any questions online, so if there's questions in the room. If not, then I would like to give the floor to Jean-Claude Bulgerman. Jean-Claude is a professor at of Open Science in the Free University in Brussels. And until the beginning of 2020, he was having the job Michael has today, heading the Open Science unit within the Commission. Jean-Claude.
Okay, so do you hear me now?
Yes, we hear you.
Okay, fantastic, because until now I haven't heard anything of what has been said. So it's a perfect example of how you need global interoperability and cooperation to make these things work. So thanks for inviting me for this panel. I do apologize that I will not be able to respond to what the previous speaker said, because I simply didn't hear it. And let me now go into what I have to say. So what I will do here, bearing in mind that Michael will for sure explain the strategies at the Commission level, is to tell you a little bit about an initiative which we have been taking since 2 years on bringing together a roundtable of so-called executives of open science clouds, or open science commons if you want it, and making them work together on the global open science cloud at the level of the executives. So the OSCAR, as we call it, so the Open Science Cloud / Commons Executive Roundtable, it's an informal club of up till now 7 persons who are in one way or another in charge of the Open Science Cloud in the world. I saw in the slides of Simon that he already mentioned those, so I don't have to mention them again. But from the European side, we have, of course, Karel LUYBEN as the chair of the European Open Science Cloud, part of it. So it's an agreement which we made to create this informal roundtable in November 2020, when we had the first Fair Convergence Symposium. And we will have the first face-to-face meeting, given the pandemic and COVID, of course, next week in Leiden, at least for those who are allowed to travel to Brussels, to Leiden, sorry, old habits. So we will have the first face-to-face meeting next week, and then we will hopefully from there on have regular face-to-face meetings to bring together these people. The idea of a roundtable is informal in Europe, but also in the US and in many places of the world. This kind of informal gatherings of people who are in charge do exist because they help them to create a platform for easy interaction, update, exchange of views, and so forth. And there are many instances to bring these people together, but having a place where no strings attached, the issues that in my country as an open science executive do occur is always very helpful in order to create consensus. So the vision is there, and it compromises two very complementary elements. First of all, a forum of exchange of views, cooperation, refining the value proposition of this initiative. So it is actually a level higher than the Global Open Science Cloud ambitions that I saw on the slides Simon has explained. It is really at the level of strategic CEO, if you want. And then secondly, it is a mechanism to allow a coordination to facilitate the collective work of these science clouds towards open science and the implementation of the FAIR principles, and ultimately, of course, to create this worldwide internet of FAIR data and services. So, concretely speaking, although we never met, and hopefully next week we will be able to go on with that, what we do is to support each other when we are asked so. So, for example, many colleagues from the European Open Science Cloud have helped the setup of the work and the expert panel and the report of the African Open Science Cloud. So that's one of the concrete examples that we have been doing, and much more recently and much more acutely we will work together on launching the support for the implementation of the FAIR Digital Object initiative, which will be fully in line with the Leiden Declaration on FAIR Digital Objects next week. So that will be one of the core topics of our discussions next week, is to what degree and how can we best support it, and why are FAIR Digital Objects so important for a global internet of FAIR data and services / a global open science cloud. So that's an important piece of work which we hope to fruitfully conclude next week. By the way, this Open Science Executive Roundtable, I forgot to say so in the beginning, is shared by myself and by George Strawn, who used to play a very important role in the past in the National Academy of Science and in the setup of the worldwide internet, to put it shortly. So why is it important to have this kind of clubs? And of course, it's not only the roundtable that makes a difference. Other initiatives are very important. But why it is important is that, you know, science is a global thing, and data-driven science ex officio is a global thing as well, and will become the main modus operandi of science anyhow. So it is very important that we work together on streamlining these initiatives. And my experience in the past with the European Open Science Cloud and the discussions we had in Brussels to set it up is that the key challenges to get all noses aligned in the same direction are not technical, but mainly governance, or CEO if you want, and how to finance it in a distributed and equitable way. So you need places aside from the institutional setups like the G20 or the UNESCO, where these issues can be discussed in order that at executive level we are going into the same direction. Secondly, the science clouds are just instruments. I mean, I'm saying just, it's of course a very important instrument, but the science cloud in itself is only an instrument to facilitate what is really needed, namely a fair internet data and service and environment. That is the glue of the global open science cloud, and not per se people working together calling themselves a global the open science cloud as so forth. So it is really important that the governance of that global fair internet data system and services is being discussed in a way that allows to really bring forward the key issues, like, for example, fair digital objects, and push for it wherever we can in our regional constituencies at the political, administrative and bureaucratic level. And then finally, of course, that there is also a worldwide movement going on to make artificial intelligence accountable and transparent. Now, an open science cloud per se will not do that. What will do this, if at all it is possible, will be a fair internet of data and services. And that, again, is a very important reason why we took, and the colleagues supported by CODATA, heavily supported by CODATA, we took this initiative to create OSCAR. Thank you for your attention.
Thank you, Jean-Claude. And a good example of another initiative, and as Simon already indicated, more top-down than bottom-up, to bring the regions of the world together in this domain. Any questions for Jean-Claude at this moment? Yeah, Karen. There's a microphone over there.
Hi, Jean-Claude.
Hi there.
What is the difference between the Global Open Science Cloud and the Internet of Fair Data and Services I think you referred to? Did I get that right? What's the difference between them?
Well, I can't see you, Karen, but I think I know who you are. So nice to meet you. Thanks for the question. Well, the difference is very simple. Where the Global Open Science Cloud is bringing together the people who do the work and trying to harmonize the standard setting and so forth. The OSCAR, the ambition of OSCAR is, in terms of investment, investment of resources, much smaller. It is bringing together the key people deciding on the direction. But the ambition is to precisely do that, make sure that worldwide the key people who decide on this are doing the same thing at the strategic level. So it is a roundtable mechanism. So it has no formal status. It has an informal status. But the history of the internet and the history of standard setting in general has demonstrated that you need this kind of roundtables to make sure that also at the operational level, more bottom-up, things go in the way we would like them to go.
If I may add to that, what Jean-Claude calls the internet, we usually call the web of fair data and services. And we see this as the worldwide web of fair data that can link to each other, which is the basis for all the exchange of data and the data sharing. So if you want to share data, either by visiting the data or by sending the data somewhere, you need to have access to the data, and interoperability needs to be secured. By making the data fair, you are, per definition, securing that interoperability. So one is more of the technical nature. The Open Science Cloud, in his definition, is more of the, let's say, people nature that does this type of work. Other questions for Jean-Claude? If not, let's move to an element of, let's say, essential let's say, compositions within creating such a web of fair data. And this is what Gabriela is going to tell us. Gabriela is the executive director, Gabriela is the manager that leads the data site participation in several EU-funded projects, and you are from the data site community. Gabriela.
Hello, and yeah, thank you so much for the invitation to participate in the conference and for all of you for being here. So today I'm going to speak about data site, DOIs, how we enable data sharing, and also how we help build a global and open research infrastructure. And for those of you who don't know much about us, we are an organization that provides DOIs, digital object identifiers, Our vision is to connect research and identify knowledge. And very important to say that we are an organization established by and for the research community in 2009. We're a membership organization, meaning we are sustained by membership fees, and we are governed by an executive board that is formed by representatives of our member organizations. Currently, we have membership in more than 50 countries. And we are truly committed to openness. We are signatories of the principles of open scholarly infrastructure, which are a set of criteria and guidelines around governance, sustainability, and technical insurance. The first two might be more self-evident. The last one, technical insurance, is basically around forkability, meaning, for example, in our case, that we have open source code, open metadata, open APIs, so that our infrastructure is replicable and open. And the services we provide to the community, the most foundational one is registration of DOIs and metadata. This is very important because it helps identify and improve discoverability and also reuse of data and also other research outputs such as models, preprints, data management plans, software, and other resources. We also work closely with the community, doing support and engagement activities. And something very important in terms of community governance as well is that our metadata schema is governed by the community. We have a metadata working group that discusses changes in our schema so that this can evolve as the needs of the community evolve. And then we propose those changes and share that proposal openly for community consultation. And we also offer dashboard and analytics and APIs that can help track the influence of research. And we want to help build an open and global research infrastructure, but we cannot do this on our own. We rely on our members to use our services to identify and connect research. And here at ICRI, there are a lot of DataCite members. Yesterday, we heard from EMBL, from Clarin Eric, from Seon in South Africa, Turn in Australia. So all those are organizations that are already using DataCite services to register and make data sets openly available. So we currently have more than 280 members in more than 50 countries that have connected more than 2,700 repositories to register DOIs and metadata with us. And this is how we enable this global scale, but making all these outputs reusable and discoverable. And we also work with local communities. Currently, we have 51 consortia, which are groups of institutions that come together to adopt DataCite DOIs in a national or more broad scale. From those 51, 26 are based in Europe, so you can see that we have a strong adoption of DataCite DOIs in this continent, but we also have consortia in North America, in Oceania, in Latin America. We have 5 consortia currently, and in Africa, the Ubuntu-Net Alliance leads a consortium. So altogether, we have more than 1,200 organizations that are sharing their research data through DataCite for the global community. And in the PID, persistent identifier world, we like to say that persistent identifiers are the building blocks of research infrastructure, And metadata is the glue that connects all those blocks together. As we heard yesterday from Hugh, metadata is super important to enable a common sharing and understanding around research, and it's also crucial to connect research and make it more discoverable and reusable. And DataCite DOIs are connected throughout the global research ecosystem through persistent identifiers. So when someone registers a DOI for a data set, in the metadata of that dataset DOI, they can identify and recognize the creators of that dataset with their ORCID identifiers. And they can also assert their affiliations with a ROR identifier. ROR is a new persistent identifier for research organizations that it's also open and community governed. And it's even possible to connect information about who's funding that research through a cross-ref grant identifier. And important to say that our metadata schema is also a standard that's globally used in the research community that allows many more connections. I'm specifically mentioning these identifiers and these organizations because they also offer open metadata. And thanks to our members that are registering research outputs and resources with DataCite and the power of persistent identifiers and metadata, research becomes more discoverable. Persistent identifiers and metadata interconnected form a graph, which we call the PIT graph, and this technology actually was built through or as part of a HORIZON project, Freya. So this is a network of PITs, and you can see on the snapshot that there are multiple entities connected. So data sets connected to journal articles, creators of data sets, their affiliations, their funding organizations, and more. And again, we offer open infrastructure, so all this information is available through our GraphQL API that is open to all. And to make this information available to the more general public, we also have a user interface called DataCite Commons. We also have a Commons, so everyone can go into the platform and search by researcher, by institution, repository, or works, and see all these connections. And here you see a raw data set about wood economics. Doesn't tell us much. But here you see the PIT graph in action. So this is a good example because it illustrates how metadata help make connections more transparent. So this is a data set that's identified with a DOI and contains a lot of identifiers as part of the metadata that make these connections visible and transparent. So if you go to DataCite Commons, you'll see the list of creators, their affiliations. In this case, these researchers are affiliated with research institutions and facilities in the USA, in UK, in Australia, and in France, so you can see the global connection there. And also this data set is referenced in an Ecology Letters journal article, and this data set itself has been cited 79 times and has more than 50,000 downloads. And on DataCite Commons, you can even see more information. So they show how persistent identifiers and metadata can help share data globally and track citations, reference, and impact. And this session is about global scale, and for us that means building bridges throughout the research community. And I'm going to repeat a little bit myself again. Persistent identifiers are powerful when interconnected and when adopted broadly. And the research community has been doing this already, and now we're starting to see some evidence. So in late September, ARDC published a report, a cost-benefit analysis, and the finding was that the Australian research sector could save $24 million with persistent identifier adoption. And last year, JISC in the UK also published a similar report with very positive results. And we see that more and more countries are working on implementing national PID strategies, and they are collaborating together in the RDA group, National PID Strategies Working Group. And now we have an emerging new case of regional and wider adoption of persistent identifiers in Europe. And the Fair Impact Project is actually also funded by HODSON and is looking to expand FAIR solutions across EOSC. Persistent identifiers and metadata are at the core of the FAIR principles, and DataCite is one of the project partners and will be working with the community to create a shared value proposition for persistent identifiers in EOSC, and to set up a coordination mechanism for PID providers in the European Open Science Cloud. And when realized, this will be the widest collective and aligned effort in terms of regional PID adoption and implementation. And we are really excited to see PIDs integrated in EOSC. And I would like to finish with a call to action. Invest in open infrastructure, so use identifiers for your data, for your outputs, include and curate metadata, and share these connections globally with the community by adopting open infrastructure providers. Identifiers and metadata can help put the FAIR principles into practice, and by making these connections, relations more open and transparent, they can help recognition for all contributions to research, so also use infrastructure to promote open research. Thank you.
Thank you very much, Gabriela, for this very clear example. Before I give the floor open for questions, I would like to mention that Simon put an answer, Karen, to your question on the questions. He gave an answer rather than a question, and he writes, the web of FAIR data and services is a vision that will underpin data access and use in the future, while the current global open science cloud initiative is a framework for collaboration. That's his explanation of the two terminology, but they are very closely to each other. And we have a lot of terms: commons, clouds, webs, internets. So it's a mess, if I may summarize it. Any questions to Gabriela? Yes, please.
I was wondering whether you're thinking about being able to link the DOIs into publication. So, for example, if you take genomics data globally, people download data, millions of genomes. They then say in the acknowledgements, these people contributed genomes, but they don't get included in publications. Are you starting to work with publishers of scientific journals to think about how this model can move into publication? Because we need to get like physics with big data.
Thank you for the question. There's some echo, sorry. It's already possible to reference DOIs for datasets in journal articles, and there are actually many publishers that are doing so and depositing first, making a policy of these data availability statements with DOIs, which is very important and crucial, and also depositing that in the metadata when then send it to Crossref. So that's already in place. We need the publishers to do it more consistently and also to put more incentives for this in general in the community. Also with citizen science, we see an emerging new case for a need of recognition of citizens that contribute to citizen science with observations and more. And for example, in this case, if those observations are recorded with a DOI or with an identifier, and then those citizens have an ID, for example, an ORCID ID. With the C for ORCID stands for contributor, so it's also possible to recognize those. So the infrastructure already offers that possibility. It needs to be implemented. Thank you.
Thank you. Other questions? If not, then I suggest we move on to our last speaker. That will be Michael ARENTOFT. I already mentioned him. He is the head of the Open Science Unit in DGRTD in the European Commission, and he will give us his view from the European Commission. Michael.
Thank you so much, Karel, and thank you to the organizers for letting me join this panel at a late stage. And indeed, as you said, give the perspective from a European open science policy point of view. And of course, in connection with the theme of this panel, it is about the European Open Science Cloud. It has been said already by previous speakers, what Simon and I call the vision. Which is indeed a worldwide web of fair data and services, and with a focus, at least in the current period, to have such a web of fair data and fair services offered to researchers. In a medium-term perspective, we are also looking at how to broaden this vision and broaden the participation to other sectors in the public sphere, and of course, also very importantly, to the private sector. So, in concrete terms, what we are looking at in terms of EASC deliverables, it's very much a pan-European network, or a pan-European federation, is probably more precise, of data repositories. But coupled to that also what we call a catalog of use cases, which corresponds very closely, I guess, also to what was previously mentioned as case studies. So it is, in terms of deliverables, an infrastructure that will make it easier for researchers to share, easier for researchers to reuse, having an infrastructure which is cost effective. Now, in practical terms, for the daily work of the researchers, it is about reducing complexity, reducing cost of data storage, of data sharing, of data management. It is about allowing researchers to produce data that are fair by design, or if you like, automatically made fair from the outset. And at the end of the day, it's about offering data integration within the field, but also, as was said previously, across fields, across disciplines, which is a real added value. It's about composing different services for researchers, and it's about putting all of this data integration, composability of services into an easy-to-use workflow in the daily life of the researchers. So in concrete terms, we have moved into a new phase of developing the European Open Science Cloud. Before 2020, we were in a phase where it was more ad hoc. We went from one funding round to the next, projects that were not so interconnected and interoperating, into a new phase that started beginning of last year, into a true partnership also. It was very much top-down before 2020 with the different states in Europe, the European Commission also more of a top-down approach, into now, very importantly, having a partnership with the research community, a partnership between the European Commission and the EASC Association, which is exactly representing the voice of the research community. Also in money terms, before 2020, we managed to put together a bit more than 300 million into mainly research projects. And now we are looking at a commitment until 2030 of more than 1 billion, at least 1 billion. And that's only in terms of the partnership as such. Of course, then within the different states, you have a lot more investments. In terms of the types of activities that we support, we're also moving increasingly from research projects to innovation projects, and we even have procurements now to set up this web of fair data and services. Now, of course, this session is about the international dimension of this. And here we are very much aware, of course, from the outset that EASC operates in a global ecosystem. So there is a need, as was also said by previous speakers, to avoid any creation of silos. And this is why, from the outset, EASC, as I said, it is a multilateral initiative. It involves more than 40 countries just in Europe. But, as I said, EASC is global in scope. It's European by focus, but really global in scope. So we very much see EASC as the European contribution to this global open research commons. Now, in practical terms, it means that on the one hand, each region and sometimes each country are developing capacities in terms of infrastructures, but also in terms of skills at a local, institutional, national, and as I said, world regional level. But there is very much a need for cooperation and alignment. I think these were the words used by Simon, on principles, on features, on attributes, I think was the word used by Sarah. And some of these features, of course, are not only technical features, but they also have to do with transparency in the governance. They have to do also with open, clear rules of participation for access to the different open research commons. This means that from a European point of view, we are proactively participating both in GOSC, in GORC. Also, I should mention the UNESCO Working Group on Infrastructures that are also looking at guiding principles and recommendations and are setting also up also global repositories. So this is also a player in this scene. Now, interoperability, we see from at least three different perspectives. You have to address it at the level of research data. So this is the connection, of course, with FAIR. And here we see very much the value of addressing this through the communities that are organizing themselves, in particular, of course, in the context of Research Data Alliance. We also have to see, of course, interoperability in terms of interoperating research data infrastructures. And here, our interest, at least to participate in these global fora, are not so much technical. They're more of a legal nature, of an operational and governance nature. That's where we see the real added value of our participation in these global fora. And then lastly, interoperability of the research services. And here it's very important to look both at the disciplinary services, but also at the cross-cutting services, the interdisciplinary services. And this is where the case studies come in as very important. The use cases come in when you look at the different disciplinary cases. So in a nutshell, this is where we come from the European perspective. This is what we see as our role of participation in GOSC, in GORC, in the UNESCO working groups, and where we come from in terms of our priorities, be they technical or non-technological, and here in particular it's issues around governance, legal interoperability, or at least compatibility. Thank you.
Thank you, Michael. Maybe you sit down. Thank you, Michael. Maybe you sit down immediately in front, and can I ask the other speakers that are here also to sit in the panel? We have 20 minutes left for a panel discussion, but before we do that, I offer the floor for questions to Michael, his contribution. Any questions to Michael ARENTOFT at this moment in time? If not, then let's start with the panel discussion. I had prepared 3 questions, which I've not mentioned, to be honest, to our panelists online, but it's a surprise for them. And I have mentioned them to the panelists that are here. The 3 questions are basically the why, the how, and the what question. Why should we do this? And I want to skip that question because as well, Simon, as Jean-Claude, as many of the other speakers have already addressed this question, why we do this. And if we do have time in the end, we may come back to it, but I don't think this is the most urgent question for this moment to be discussed. What is needed and what is wanted to think globally in the domain of data sharing? The next question is how? How can we see to it that this global interaction between the regional approaches is best established? And we've seen a few examples of the how already again in the presentations, so I for the time being skip that question also because the how is being done by different organizations. Nevertheless, if you want to come back to that question, you're happy to do so. I would like to concentrate on the what question. The what question is what needs to be done at the, let's say, interaction to make this a reality. What in terms of standards, what in terms of arrangements, what is needed to make this global approach, which we all see as essential if we talk about, let's say, combining, sharing research data. Research is global and interdisciplinary if we talk about, let's say, the real issues of the world. What is needed in order to make that a reality? And maybe it's good to start backwards with the speakers and end with Simon, and I'll start thus with Michael. There is a microphone here. So, what is needed?
Let me start with the technical issues. Many have said that this is the glue. To have data, to have services that are fair. But we have to consider that in the full sense of fair. We have heard about the importance of PIDs. Very important that there are convergence on that, alignment on that. We have heard about the importance of using metadata standards. I think you mentioned that as well. There's a third one I would like to add, which is the R in FAIR, which is about the reuse, which requires also discussions around licenses. So this is what I want to say on the technical side. On the non-technical side, I mentioned already the governance. Indeed, it's very important from each of the different initiatives from the outset to be open, so to come with a principle of openness and to have from the outset an international openness or combined with that an international outreach as well, that international players can come both as users and as providers to the different initiatives, and connected to that to have rules of participation that allow that to the extent that this is possible also in legal terms, and that is the second non-technological barrier that needs to be addressed, because although of course science is global, although the data sets also should be globally reachable, when we talk about infrastructures, initiatives, policies as well, they are set locally, they are set institutionally, nationally, sometimes regionally, as we see in Europe. So to combine this with the rules of participation is not always straightforward, and that's as I said before, is why we need these global fora, because we live in digital, we live in different legislative environment, we live in different political environments. Reciprocity is another aspect of governance, I think. And
it's
the
either dark or light.
On and off. Reciprocity is another aspect of governance in addition to the legal and the rules of participation aspects. So this is what I think about the what. Of course, I could dwell more about the why and the how, but I'll let other panelists intervene.
Thank you, Michael. And let's move back in order to the two speakers that have given a much more practical approach, the DOIs or the PIDs and the attributes of which the PID is one.
So in terms of the why, I think...
The question was the what.
Sorry, in terms of the what...
I would like to concentrate on.
To add with...
What needs to be done in order to get this globally connected? In your case, what needs to be done in order to get the DOIs operating globally?
I think the infrastructure, there's already operational infrastructure that allows this on a global scale. That's already in place. It might not be perfect, but at DataCite we believe progress is better than perfection. I think what's needed is more incentive and more recognition, because it takes a lot of time, especially, for example, to early career researchers to publish a data set, a lot of hours of work, but there's still not enough recognition for this work around data. Now we're seeing in Europe and in other regions of the world this rethinking around research evaluation to make it also more open and inclusive in terms of recognizing scientific work beyond journal articles. So that's really important, and also a commitment from the global community as well to support open standards and to support service providers, infrastructure providers, system providers that allow for this interoperability and do not operate in silos.
If I understand you correctly, you say it's not so much the technical, it's more the willingness issue. Would it help, as a suggestion, if we would oblige every researcher that is being given money from the government, from a science funder, from the European Commission, to put his or her data that are in the publication, because if they publish it, they are open. You can buy the journal, you can read, and you can have the data. To oblige each of these researchers to make those data as fair as possible, see to it that there is a DOI, and see to it that they get reposited, that they get stored in a proper repository. They cannot object for the data not being open because they are open.
I think it would help. A mandate would strongly help, but we also need to make it easier for researchers to do this, because otherwise we keep overburdening the researchers. Yeah, I think with the EOSC, Fair of Data, and integration of PIDs, this data exchange should run more smoothly. So I think we're making progress in that direction. Helping them with data stewards and with technology. Karen, what's your view on the what is needed for the attributes you are talking about?
Well, first I would agree that better recognition would certainly help in a number of ways. It would certainly help increase the pipeline of talent that's going to be needed to manage these systems and move these systems forward. So I absolutely agree with that. I do believe that part of our approach to finding attributes amongst commons is about finding commonalities, and as you said, not overburdening people that are already overburdened. So try to find areas where there's already energy and agreement and uptake, and try to build on that. I would also say that I feel like, and maybe this is just me, I feel like there isn't enough robust conversation about the impact of Amazon, Google, and Microsoft in the research space. And as an American living in Canada, I feel like I can call them out forcefully and say that they're benefiting from the taxpayers' money in ways that are in some ways appropriate, in some ways I think probably inappropriate, and will at some point be a hindrance to global integration, I think. And I think there's a lot of problems that I feel like we're kicking down the road, and I would rather see, and maybe there's a forum out there but I have yet to find a robust forum that is really talking about that in an honest way. But yeah.
Yeah, thank you. I should have actually asked Jean-Claude first, but I will come to you, Jean-Claude, in a minute. The three you mentioned, Microsoft, Amazon, etc., they already have more than 80% of all the data on students and their, let's say, achievements from the Dutch universities. We have just found out. So it has been increasing from, let's say, 10, 20% The last couple of years, last, let's say, 7 years, up to 80% now, which is, I think, alarming. Jean-Claude, what is needed, according to you, in order to make this, let's say, global approach more of a reality?
Yeah, well, first allow me to react on this Microsoft Amazon thing, because that was exactly one of the drivers why we started the European Open Science Cloud Policy Initiative, to make sure that the research data in Europe are not only hosted on the servers of those companies and companies in general. And as Karel just indicated, the situation is only getting worse. In my view, I think that there are already much more premium contracts between European universities and these big providers than whatever we will able to grasp. So very short, Karel, I think technically speaking, the real thing, what we really need, given that all science will become data science and will be machine actionable and so forth, is the FDOs. We need to work on a global fair digital object implementation as soon as possible, but that is only a technical thing. It's not trivial, but it is not really rocket science to implement it and to make it happen. Technically speaking, we can do it. Incentives-wise, I think funders and universities should be mobilized. Funders should make it mandatory to do it. Universities should include it in their evaluations and so on. Because we have this discussion about incentives and the people don't have enough time and they need the skills. You know, this discussion is going on from day one we started working on open data, and the only way to break that circle of there is not enough time, not enough skills, not enough money is by just making it happen, by including it in the funding, by including it in the evaluation schemes and so on. It's a vicious circle, and it won't happen spontaneously, or if it happens spontaneously, it takes a lot of time. And that brings me to my third thing. Listening this morning and being a veteran of all this and being on the sideline, because all of you are there on a daily basis, and I no longer had. A lot of what has been said many times over and over again. I really think that technically we know more or less what we need to do. I really think that in terms of incentives and in terms of skills, we know what we need to do, more or less. I mean, we don't have the blueprint, but we know the direction. We absolutely know it. The only thing that needs to be done is to make it happen. and there, I think we cannot rely on politics or on OECD circles or on UNESCO circles to do it, because my experience is, working for the commissioner in those days, as soon as you get in those, that day is over. We have the political support, and if you push it back there, I think you will get into much more problems than solutions. So I'm a big fan of having 2 or 3 of the key players in the world of science coming together, agreeing on it and doing it. And I do think that the world of science has to push for it. So if the ISC wants to play a big role in it, I think that's probably a welcome forum. And if the US together with Europe, because the US with the OSTP now is on the same par and actually is a bit more precise and more ambitious than our policies. Now, if those 2 big mammoths of the world of science would just agree on doing it, well, then it will happen. But all the rest is trickle-down implementation. It is the linchpin that we are missing to kickstart it and to make it really happen. And conferences and discussions and PowerPoints are needed, but they won't make it happen in reality.
Do I understand that you are in favor of some more pressure and some more, let's say, mandatory things?
No, I don't hear anything anymore.
Okay. Then we go to Simon. Simon, it looked like you were escaping the question, but you came back. So what, according to you, is needed in order to make this happen? You addressed some of that already in your speech.
Yeah, and I agree very much with Jean-Claude that we have a good idea of what needs to be done. I think there's been some very good work done over the last few years to lay out the roadmaps and the frameworks. I would say this, wouldn't I? But I do think the Turning Fair into Reality report lays out a set of actions. I think the adaptation of that for the EOS-SRIA is very clear and we know what to do. I think the listing of actions in the UNESCO recommendation is very clear. We have a set of priorities there. The challenge is that these things are so complex, interrelated. And so we cannot do other than do them all. We need the policy interventions, we need the technical infrastructures, we need the human capacity. And yes, we need the change in culture. And so it's a little bit counterproductive to say what's the most important, because they're all interrelated. And I think it's worth making that point. And yet, at the same time, yes, we do need fundamentally different priorities in our science system. And if we have to point at one thing, then it's that. Let me give a very quick example. We're working with a project who's done some excellent work, some really good research, some really good data integration research, or integration practice, and has published a whole load of articles about it. But that's their priority. And what have they done? They've combined data from a whole load of different sources, and they have not used available international standards. We had a session with them and said, why did you not use Standard X? And I won't say which, because that might point out which project it is. They have reproduced a whole load of work that could have saved them time. And now, if they want those data to be used by other people and to be interoperable and deposited in a trusted repository, they will have to recode all that data. It's impossible. Why did they not do the standard? They weren't aware of it, and it wasn't high up in their priorities, because their priority was the publication on the basis of the research. And although the research is very strong, I'm sure, although the data collection and integration exercise was very good, we have to have doubts then about the reproducibility of those research, of those findings, because they can't properly be compared with other research in the same field, because they've used their own bespoke standard. Now, that's a problem of misplaced priorities in the science system. And ultimately, if I have to stress one thing, it's that. I'll end very quickly on, there is so much to do. We have to be both humble and ambitious. I like the phrase festina lenta, make haste slowly. It's an enormous task, and it will not change overnight. And yet, as William Gibson says, the future is already here, it's just unevenly distributed. And I think one of the things that we can do is point to extremely good practice as it emerges in those infrastructures, those research groups, or those domains or subdomains which are really making astonishing progress because they've harnessed fair data and the technologies of the 21st century.
Thank you, Simon. Somewhat more mandatory, sufficient help, and sufficient, let's say, knowledge that the incentives are there. Questions from the audience for our speakers? Yes, please.
I'd like to offer a comment as well
Go ahead.
To the discussion. And it's related to perhaps what Gabriela talked about before, and particularly the adoption of IDs, whether they be DOIs, PIDs, whatnot. It's a question of carrot and sticks, and there's an existing stick today that you referred to briefly in your response to a question from the audience earlier, where you talked about the publications. So journals today are demanding of authors that they do include a reference with DOI to the data that they've used in the publication and the work that they've done, as well, and it could be a DOI to an existing repository of the raw data from somebody else, like a research infrastructure that they may have used. And on top of that, that they publish the results, the data results of their publications in a repository with another DOI. And on top of that, there's a requirement now as well that software used, the software developed in the framework of the work that's being published, is also deposited in a trusted software repository with the appropriate DOI as well. So I was editor-in-chief of a journal of the American Geophysical Union, and they're pushing this policy very strongly. So authors, researchers are going to be getting used to this policy, and that's how adoption will take place, by using this little bit of a stick. And so I think things will change from that perspective.
Yeah, thank you for that comment. Very much in line in what I suggested. The publication is there. Why not have the data in the publication at least available also and referred to? I'm not sure whether it should be the publishers that ask this and demand this. I think it must be more the funders and the leaders of research organizations that ask this and demand this. If the publishers ask it and demand it, they will also own the data as far as they are possible. Well, it's not allowed, of course. No, I agree with you, it's not allowed. But they will try to, at least, some of them. Other questions or remarks? Giorgio. The microphone is coming.
Thank you. I think the bottleneck that we have to overcome to make all this a success story is that we have to make effortless at the entry level the supply of good quality fair data sets. And when I say effortless, I mean it. So we cannot reward or convince or fascinate the researcher to do something that is outside of his main mission, that is to perform research. But what I'm saying is that there is a technology development, a technology barrier now to have directly fair data sets coming out from our laboratories, observatories, research infrastructures, and etc. And this is what I think should be pursued, because only the moment, the day we will have a large set, a big number of fair data sets interoperable, then artificial intelligence, governance, and everything start to make sense. These things made sense in the commercial world, not for science data, because they took huge amounts of data the easy way, stealing them or sensing your presence in front of a window shop for more than 10 seconds, and all that of things has created a huge data set. Then artificial intelligence operates. If the data sets of research will remain a marginally small part of all the new data, the thing will not work. So effortless, high quality, fair data at the entry level to make the whole thing successful. Thank you.
Thank you, Giorgio. Effortless is only possible with help, of course, so I understand that you also advocate help. And there I would like to make a call to the leaders of research performing organizations. They very often say, who's going to pay for that? Because it takes more money. And then I answer, no, it's not going to take more money. You're going to use your money differently. Rather than spending it on the 21st PhD student, you spend it on a data steward that can help the 20 PhD students you already have. And then they say, well, yeah, but we need the researcher. We should not give the money away to other things than research. And then I ask the question, do you buy computers? Yes, of course they buy computers. Why should you do that? You can also do it by hand and by putting it in a notebook. That discussion took place when the computers came into the labs. Everybody said, this costs money, we cannot afford it, so we're not going to make that transition. Well, they made a transition clearly, and this transition is going to be made as well. Yes, money can help to make the transition faster. Therefore, I stimulate research funders, I stimulate governments, I stimulate the European Commission to give transition money for the next, let's say, 20 years. But we have to do it with the money that's available for research. And with that, I would like to close off this session. And thank you very much for being here and for your attention. I would like to give a big hand to our speakers.